All right, today is our last lesson in unit number 2, representing proportional relationships. So our essential question for today is, how do we represent proportional relationships? This is our essential question. Again, you should be able to answer this by the end of the video. All right, so if a relationship is what we call directly proportional, it has the equation of y equals kx. So when we use the letter k, K stands for the constant of proportionality. Remember, that is similar to the unit rate. Okay, so I talked about this in the last lesson, but today we're going to be working more with tables and graphs, and again, we are going to be focusing on the form of the equation y equals k times x, and k is that constant of proportionality. So if we look at example number 1, we have the function table shows the relationship between the sides and lengths of a regular octagon and its perimeter. So the first thing I want to point out is when it says regular, that means that all the sides and all the angles are equal. Okay? When we do our section on geometry, we will revisit that again. So regular octagon, that just means that all the sides are the same. For this one, we just need to know the sides. So what this says that if the side length is 1, the perimeter is 8. If it's 2, the perimeter is 16, and so on and so forth. So what we're going to do is we're going to try to find the relationship. So as you can see, as this side goes up by 1, and you should remember doing this, as this goes up by 1, this side goes up by 8. Okay, so now we're going to try to figure out which is x and which is y. So what you need to say to yourself is which depends on the other. So the only way we can find the perimeter is if we know the side lengths. So this we call the independent variable, and y is the dependent. Okay, so x is the independent variable. Okay, so if you think of the word independent would mean like you live alone, right? You guys are dependent on your parents, right? They feed you, they buy you stuff, you know. Okay, so this will be the dependent variable. So the only way we can figure out the perimeter is if we know the side length. All right, so as you notice, I have the next thing we need to do is we need to write down y over x. All right, y over x is how we can represent the constant of proportionality. All right, so k is actually equal to y over x. So if I do that, I get 8 over 1. So if you look down here, all right, that's actually the equation of how to find the perimeter. But it kind of assumes that you know how to figure this out. So the background behind all of this would be the constant of proportionality. So y over x, using this table, we can figure out what the equation is, which is P equals 8S. And if you think about it, that makes sense. So an octagon has 8 sides, and in order to figure out the perimeter, we actually just add up all the sides, right? Well, if all the sides are the same, that means instead of adding, let's see, this would be 9 inches, right? Instead of doing 9 plus 9 plus 9 plus 9 8 times, we can just do 8 times 9 and get our final answer of 72. Okay, the next thing we're going to talk about is a linear relationship. So a linear relationship, that is exactly what it sounds like, okay? Linear means line, all right? So every single equation that we figure out, these all are going to be a line. It's always going to come out as a line, okay? So a directly proportional relationship is a linear relationship because it forms a straight line when we graph it. All right? This also has to go through the origin. It only needs to do those 2 things. So number 1, it has to be straight. Number 2, it needs to go through the origin. Remember, that's 0, 0. So if you can't do that, then it does not work. So if we look at example number 2, an empty swimming pool is being filled at the rate of 10 gallons per minute. Okay, so they're giving us the rate. And we want to figure out how long it will take, or what amount of water would be after 6 minutes. Okay, so that's what we're trying to find right here. Okay, we don't know that. Okay, so in order to do this, I know that 10 gallons per minute is my unit rate. That is my constant of proportionality. Okay? That is my letter K. All right? So this right here is what we need to multiply by. So now if we were to think about it, all right? So the number of minutes would be my X, and then my Y is the number of gallons, because the longer, right? The longer we fill the pool, the more gallons of water are going to go into the pool. So it only makes sense that as time goes on, right, minutes, so remember, time always goes in the denominator, and that makes sense because if we do what our constant proportionality is, which is y over x, okay, that makes sense because time is in the denominator, all right? So the important thing, at 0 minutes, there should be no water in the pool. After 1 minute, there's 10 gallons because that's a unit rate. Then after that, each time the minutes goes up by 1, our gallons goes up by 10. So remember, the purpose of this is so that we can graph it. So right below, you have your graph. All right, and again, all that is we took the function and we plotted the points. So 0, 0, 110, 220, okay? This is what you should have if the line wasn't already drawn for you, and then you connect all the points. Make sure that you connect all the points. We see that this is a straight line and that it goes through the origin. Remember, it has to do both. Okay, question number 2. So the graph shows the amounts charged for purchasing different numbers of roses from a florist. Is there a proportional relationship between the number of roses bought and the cost? If so, what is the constant of proportionality? So now we're kind of working backwards, all right? So what I want you to do is I want you to look at this graph. So the first thing I know is, yes, let's write it this way. So when you're looking at these, we need it, okay, straight. Sure is. And through the origin, yes. If you could say yes to both of those things, then it is a proportional relationship. So now we have to figure out what is the constant of proportionality. So what I'm going to do is I'm going to write down a couple points. All right. Okay, so remember this is x and this is y. So let's look at a few. So I have 2 over 1, all right? So the coordinate 2, 1, that equals 2. Okay, the next one I see is 4 over 2. Well, that also equals 2. The next one I see is 6 over 3. Oops. And the last one I see is 8 over 4. Okay, so these are all the same. Check, check, check. All right, so since those are all the same, this is definitely a proportional relationship, and the constant of proportionality is 2. Okay, so that means that each rose costs $2. I don't know if that's expensive for a rose. It's kind of expensive. Probably cheap though, who knows. Alright, so let's do this final example together, and then you can do your homework. Alright. So, movie theater charges $16 for 2 tickets, $34 for 4 tickets. How much would it cost for 12 tickets? Okay, so we are going to try and write an equation for this. Okay, so what I'm going to do first is, and I'm going to do that over here, so it says 16, so remember money always is on the top, and we'll have the number of tickets on the bottom, okay? Remember, because y over x, right? Y over x. Okay, so I get 16 over 2, that equals 8. 32 over 4, that equals 8. So this means that it would be $8, so K equals 8. And remember, our formula is always y equals kx. So our answer up here is y equals 8x. Right? So if I order, or if I have 0 tickets, it is $0, 16 tickets for 2, 32 for 4, 48, sorry, I'm doing my best, 64, 80, and 96. Okay? And then what I'm going to do is I'm actually just going to lay my graph right over here. Okay, so on your graph, this is what it should look like, okay? So I'm going up by 2s for the number of tickets, and then I'm going up by 4s for the cost of the movie ticket, all right? So you plot all of your points, and then you make your straight line. And again, you should always be numbering everything, okay? So then our final question. So the graph passes through the point 1, 8. So 8 is the constant of proportionality. And then if you look on our chart or on the graph, it would cost $96 for 12 people. All right, so that's all.